Usually when we think of AI, generative AI, we think of systems that give us a single answer or a prediction like this is a cat or sales will be exactly 10 million next quarter. Probabilistic AI now takes a fundamentally different approach where it says, okay, I think this is a cat, but I'm only 85% sure. Or sales will likely fall somewhere between 9 million and 11 million. So the core idea is to build systems that not only make predictions, but also explicitly quantify and reason with the uncertainty. So it's about representing knowledge as degrees of belief, and all of this resting on probability theory.
Welcome to ODSC's AIX podcast, your gateway to the latest in AI and data science. This episode is sponsored by ODSC East, the premier AI Builders Conference, celebrating its 10th year this May 13th to 15th in Boston. Learn more at odsc.com/Boston and use the code ODSC Podcast for an exclusive 10% discount. Hello, everyone. Welcome to today's podcast. My name is Alex, and I'm the head of content here at ODSC. Today, we're speaking with Thomas Wiecki, the co-creator of PyMC, the industry standard tool for statistical data science in Python. Today, we're going to be talking about Bayesian modeling, probabilistic AI, and marketing mix modeling, among other tools. We'll also be talking about PyMC, a bit of Thomas's background, and getting into his ODSC East session in a couple of weeks. So with that, Thomas, thank you so much for joining me today.
Thanks for having me. Excited to be here.
So first of all, tell me a bit more about your background, how you got to where you are today, and what led to PyMC.
Sure, happy to. My name's Thomas, and honestly, I've always been very fascinated by computers from an early age, and really the idea of how can we use them to understand the world around us. And that then led me to study bioinformatics in university, where I got really interested in data science. And then algorithms and techniques like machine learning and neural networks really grabbed my attention just as these incredibly cool algorithms. But like many, I was thinking, okay, that's really cool, but how do you use that to solve meaningful real world problems? And to try and tackle that, I started a PhD in studying computational psychiatry at Brown University. And the whole premise of that field is exploring how we can use computational methods to help us better understand and even treat psychiatric conditions like schizophrenia or depression. And that's where I found two really valuable tools for answering these really difficult questions. So mainly we were using neural networks and Bayesian models side by side. And neural networks, machine learning definitely is fantastic for dealing with when you have lots of data, you want to make the most accurate predictions, but they usually are black box tools. So they can't really tell us why they arrived at an answer. And that's where I think Bayesian modeling really has an edge, where it's for me, the perfect tool for analyzing very specific types of data, such as what we're getting from experiments. So this was neuroscience and psychology data, and then building these very targeted interpretable models to answer very specific research questions. And critically for science, especially, these Bayesian models provide uncertainty estimates. So we really can say, okay, how confident are we in this answer? And that's also just because I had this computer science background. I really got excited by using PyMC, which was open source project back then, which we're going to talk more about, and started also contributing there back. But I remember that even 10 years ago during my PhD, seeing those two things side by side and wondering like, how can we really combine the AI neural networks with Bayesian modeling to get the best of both worlds, the scalability and predictive power with the interpretability and uncertainty quantification of Bayesian methods. And what I'm really excited about today is that I think this is the perfect time to really start and integrate those two approaches together. So that's for the motivation. And Then after I finished my PhD, I went into industry, joined a startup in Boston called Quantopian. And that really enlightened the fire, where I saw how a small dedicated team could have a big impact and build these great ambitious products. And that was super inspiring to me. And then after Quantopian, having this community around PyMC and the talent that has joined and helped contribute, and we all gotten really close, it became quite obvious to just start essentially PyMC Labs, the consulting company that builds on top of the open source tools and uses them to help clients leverage this power of technology to bring cutting edge probabilistic methods to solve really complex business challenges.
Great. That sounds like a very helpful tool. PyMC, that is. So before we get into the details of the tools, what exactly is probabilistic AI and how does it differ from typical AI systems that we normally hear about?
Sure. Yeah. Usually when we think of AI, generative AI, we think of systems that give us a single answer or a prediction like this is a cat or sales will be exactly 10 million next quarter. Probabilistic AI now takes a fundamentally different approach where it says, okay, I think this is a cat, but I'm only 85% sure. Or sales will likely fall somewhere between 9 million and 11 million. So the core idea is to build systems that not only make predictions, but also explicitly quantify and reason with the uncertainty. So it's about representing knowledge as degrees of belief, and all of this resting on probability theory. And like I said, what's really exciting now is that we're at this convergence point where we have really sophisticated Bayesian modeling tools with packages like PyMC that have become really powerful, and we can build large scale, very complex models and complex causal interactions. And simultaneously generative AI, which obviously has exploded and does a lot of new capabilities. And this now finally allows us to build these integrated systems where we combine the advanced probabilistic reasoning with large AI models to create something that understands the limits of their own knowledge and can make smarter, uncertainty-aware decisions.
I like that approach. It sounds a little more realist in the sense that humans aren't usually 100% certain of things. We'll say, I'm 75 to 85% sure of this. That seems to, under-promise, over-perform to a degree, stuff like that. On that, what are some common misconceptions or hurdles that people face when adopting probabilistic AI?
Yeah, usually when we deal with these generative AI systems, we all know that hallucinations, for example, are like a big problem when employing them, right? They just like give answers, and they also pretend to be quite confident in them. I remember a couple of months ago when a new model came out, and I had a really long discussion about like how many R's on strawberry, right? This like very common, well-known example. And I just couldn't make it see how it was actually much more uncertain about the number of R's in strawberry, right? So it insisted it had 2. And yeah, so that I think is just an inherent problem. And especially now that we're starting to use these tools in just production level systems, right? So I think there's a lot of danger there. And just modeling the uncertainty helps us in a couple of key ways. So one is we can identify unreliable outputs. If a model tells me, okay, this is the answer, but I'm actually quite uncertain in this, that's a crucial warning, right? So it means I need to maybe get more data or just not rely maybe on that for critical decisions. So the AI can say, hey, be more careful here. And also having this uncertainty allows us to manage risk proactively. So knowing the range of possible outcomes and not just the average or the single most likely one changes how we can plan and implement that plan. We can choose strategies that are more robust and perform reasonably well, even if the future is slightly different than our best guess. And the last aspect of probabilistic AI is around active learning. So if the agent knows basically what it doesn't know, it can then proactively seek out more data and information around that. And so Bayesian optimization is one of those examples where we have regions in the parameter space that are very uncertain, and then we specifically sample there, or the AI system can suggest to run certain experiments to do that. So yeah, those are some of the problems that people have and how probabilistic AI can help remedy them.
Great. So would you say that probabilistic AI is more trustworthy than other approaches, or is it just transparent about what it doesn't know?
Yeah, so I would say it's really both. So from that transparency and the AI basically knowing about how the causal structure is basically structured in this place, then the AI can say, okay, this is how I arrived at this particular answer. And that, well, builds trust, right, in the user when you actually ask it, okay, yeah, how did you come up with that answer? And it used to be that we just had the output of the LLM, say, and then it would the reasoning behind that answer would just be hidden somewhere in these billions of parameters, right? And of course, then the big breakthrough recently was these thinking models where we have like a reasoning process laid out, and that already helped a lot. But I think the next stage for that breakthrough will be where it's not just like reasoning in text and thought, but really having basically quantitative thoughts, right? And as part of that, have causal hypotheses about how the world works and able to use those to reason and come up with, these answers that are quantitative and incorporate uncertainty as well. So I think that's how this transparency can lead to trustworthiness in building these systems.
That's always what I want to hear. Cool. So you had mentioned in our email marketing mix modeling. So how does probabilistic AI come into play with that? And what is marketing mix modeling?
Yeah, marketing mix modelings, MMMs, is something we're doing a lot with at PyMC Labs. And it, at the core, asks the question, how effective is my marketing? How effective is my marketing that I do on Google and Twitch and all these different channels? And we've done a lot of work building Bayesian models around MMMs, which just is the perfect framework for building these models, because uncertainty obviously plays a really big role there, because we have little data, we have a lot of knowledge about the structure, and often also a lot of knowledge about the causal effects at play of how, certain actions we're taking or certain effects are influencing ultimately the sales or the output variables that we want to explain with this. And those type of models can get really rich and complicated, but where it gets then really interesting is when we layer into a probabilistic AI system. One approach that we've taken and one thing we developed, which is, I think, really interesting and we're like getting a lot of great feedback on, is this AI agent. So essentially, this is an AI agent that uses PyMC marketing and the Bayesian model under the hood. And now a marketer or an analyst can just ask the agent. So for example, often a question that a CMO might ask, are we seeing saturation effects in our search ads? Or how close is this channel to saturation? And the AI agent just understands this, right? You just type that in, and then the agent accesses the probabilistic model and knows how to run that and analyze it and understands all the nuances of it, and then provide a human understandable answer. So it might then say something like, our analysis suggests search ads are showing signs of diminishing returns, particularly beyond, 10K or something. So beyond that point, we're seeing saturation effects. And then maybe to support that, we get like a nice plot that explains this. So before, this was all done in dashboards, right? And you had to like really know what are the plots and the things to look at and combine information. But now the AI is creating like a very custom answer, giving you really only the information that you need, so we don't have that information overload. So yeah, it makes these complex Bayesian causal models a lot easier to interact with and understand. And the final point I want to make is that where I think then this becomes really powerful is when we are talking about taking actions on this. Having insight and analysis, like I just said, is great, but the agent now understanding the marketing data with causal insights, we can proactively suggest optimal and robust budget allocation changes. So the model can then basically say, okay, marketing spend for this particular channel is too high. Also considering the uncertainty in that, would be better to reduce this. Or even more interesting, the uncertainty here is too high. Maybe we should run a targeted lift test to gather more data and reduce the uncertainty before we are able to really make that big spend decision. So that goes back to what I was saying, that the AI now knows what it doesn't know and also what to do about it. And then basically tell the user, okay, yeah, in order to make the decision that you really want to make, we got to have more information, more data, more certainty, and then we can suggest what action to actually take based on that.
Great. So it sounds like this provides tons of insights. So what are some of the more surprising insights that you've seen with real marketing data, in the sense of maybe interesting case studies, ROI, anything like that you can share?
Yeah, one sort of unexpected, interesting thing that starts happening once we have these AI systems and they, like, for example, the MMM agent, is it becomes very natural to then start and layering on more functionality. So, for example, we have this agent and it works, but now we're like, okay, what also is important for really a comprehensive understanding of marketing and what actions to take? One of those is customer lifetime value modeling, right? Or price elasticity models. So all of these interact with my marketing effectiveness. And before, we would usually treat these separately, right? So you have an model, you have a CLV model, each of those individually, like very complex models. But with probabilistic AI, it now becomes quite natural to just start and combining these models, right? So we have an agent for customer lifetime value, price elasticity, and we then, when combining them, we see these knock-on effects across different business areas. So we get this integrated view that then provides much richer insights. And the agent basically being able to orchestrate and talk amongst each other and devise like plans that are much more complex than if you just had this like very narrow view into this, into only your marketing effectiveness.
Great. Sounds very helpful for especially from a marketer perspective. Of it sounds helpful to work within a degree of certainty rather than just a solid guarantee. So we just spoke about marketing a lot, but how can probabilistic AI help with other fields like finance, healthcare, or even policy? Anything like that?
Yeah, there is one other area which we're also actively working on around synthetic consumers. So traditionally, when you have, for example, a new product that you want to bring to market, and actually there's also a lot of work that is going on, and we're also doing about using AI to develop new product ideas, right? It can be your creative team. But then the question is, okay, we have a couple of ideas. How do we evaluate which of those are actually good ideas and which of those are not? And you used to just run surveys then, right? To just ask consumers, okay, what do you think of this? And they would tell you, and that is pretty much the best you can do other than just like actually testing it in the market. But there's a couple of downsides. One is it's slow, it's costly, right? You need a lot of people to provide answers. And it's actually also not as reliable as you would hope for what you're paying. So a lot of times you get something that might be looking extremely strong when you ask people about it, but then when it actually is on the shelves, they don't really buy it. And that's where synthetic consumers are, I think, really interesting. And the idea behind that is you, instead of asking consumers, you ask the LLM, what do you think of this new idea for a toothpaste, like glow in the dark toothpaste, for example, some wacky idea. And then the AI will have a response to that, right? We're like, I don't know, I'm worried about chemicals in this, or yeah, that sounds like a fun new thing to try and I might pay this amount for it. So initially when I heard this, I was like, can that really work? But remembering that these AIs are trained on immense amounts of human text, right? And essentially trained in a way to replicate and mimic human responses and behaviors as close as possible, it does make sense that they would have meaningful, similar responses to real humans to certain ideas. And in our own research, we've seeing exactly this. If you present them with some like terrible idea, right? They will tell you that it's a terrible idea and they would never, ever buy this. And we are running a study where we actually have a lot of survey data on your product ideas and then just trying to replicate that with the AIs. And we see actually that it's doing quite a good job in doing that. So yeah, I think that's another really interesting application area, and also something which you can then, of course, bring back into the rest, right? So I was talking about how we can, once we have a single probabilistic AI system, we can start easily then integrating that with other ones. For example, like testing the creative of a new marketing campaign on synthetic consumers might inform what we estimate the effectiveness of that marketing will be. So we have working together with the synthetic consumers, evaluating the creative, and yeah, just provide a much richer view and predictive system of what we can do. And yeah, then like placing that into an optimization loop, you can like, you see how once you start thinking along these terms, it just becomes incredibly exciting, and all the potential of just, yeah, building richer and richer systems that provide a lot better strategy and forecasting into how we think, yeah, how our business is going to go unfold.
No, it sounds like they can essentially work with each other, that they're not necessarily siloed into just marketing, consumer, whatever. You build one up and an accidental focus group almost of you have the consumers talking with marketing data. All right, I look forward to seeing where that goes. So I want to take a step back to one of your specialties, which is PyMC. So what does it do and why is it important in the realm of probabilistic modeling?
Yeah, PyMC is an open source library in Python for probabilistic programming. It's been around for a while, and really it provides the fundamental language and engine for traditional humans, but now also AI systems, to define custom Bayesian statistical models. So the way it works is you specify your prior beliefs. What do I think are likely plausible parameter ranges? For example, what do I think is the return on investment on my Google channel, right? So that maybe I have a lot of uncertainty around this, right? But there will be some range where I have a knowledge about, and incorporating these prior beliefs into my analysis helps a lot, especially when we don't have a lot of data. So we find when working with clients, I mean, they have done marketing long before anyone has talked about them, right? So they know a lot of things already, and we can take those insights and incorporate them. Not only do they have knowledge of parameter range, but also about the causal structure behind this, right? Like which factors are important and which factors influence which other factors. So both of those we can incorporate into a Bayesian model and then write that down in PyMC. And what's critical is that PyMC not only provides you with the API to write this down, but then also has state-of-the-art inference algorithms that no matter what model you write up and throw at it, it will just run the MCMC or variational inference to get at the posterior distributions. And those posterior distributions are really the holy grail of what we're after. And they represent our beliefs and crucially incorporate the uncertainty we have about this. Staying with the example of the ROI for a particular marketing channel, we start with some belief around, okay, maybe it's 10%, between 10 and 20%. And now after having seen the data and fit the model, I think it's between 14 and 16%, right? So by observing data, we narrow it down to a smaller range, but still a range. And then we have uncertainty around that. Yeah. And I think it is a critical tool in this probabilistic AI sort of world because it allows us and provides the AI with the tool to perform these complex causal reasoning about the data and decision-making under uncertainty tools. Yeah, that I think is what PyMC is about. It has a huge community of users and contributors. And then PyMC Labs is basically how we leverage that tool to solve applied business problems.
Cool. So since it is open source, how has the community improved it? And in turn, how has the community helped solve more complex problems?
Yeah, having PyMC always been open source and also building a business around it has just been amazing, and so many benefits that weren't even obvious from the beginning. But one of them is the accessibility, right? So it's open source. Anyone can use it, modify it, learn from it. There's no vendor lock-in, right? Any solutions that you build based on top of it or we build will always be free, and you can change it however you want, especially for companies that already have a data science organization and doesn't want vendor lock-in. That's really compelling. But yeah, so for me, biggest benefit and source of enjoyment is just like the community, putting something out there and then having people find it really useful, get excited about it, start contributing back. And here's a cool new feature I implemented, and here's a bug fix. So that I find is just immensely powerful and the best way to build software, right? Linux is another great example where and for me, like, it's always been such an interesting conundrum in a way that highly paid software engineers working at companies developing closed source software often fall way short of what just like hobby programmers in their free time can do remotely without knowing each other, and just like in this decentralized way and working together very effectively despite not knowing each other and not sitting in the same office. And that is also fascinating in how innovative that is, right? This decentralized group of developers, you just get the best minds from all over the world, right? Just like starting contributing and developing really amazing things. And that's also, I guess, for myself personally, and also in PyMC Labs, where a lot of us come from academia. So I wholeheartedly believe that the best mindset to innovate is we have this freedom, right? Where there's not sales targets and tight deadlines and sprint plans and all of that, but you can really just explore and have fun with it, right? And that's where the best ideas come from, and where I think the highest level of innovation can happen.
Right. There's no corporate goal, ROI, objectives to meet. It's just people being creative and making a better product for the sake of making it good.
Yeah.
So for the people who haven't used it yet, is there a learning curve to pick up PyMC, or what skills should someone know, or tools should someone use going into it?
Yeah. I mean, I would say that PyMC has made building complex models much easier than it was before, where you spend a lot of time trying to have intuitive API, extensive resources, that automated inference engine I talked about. So it used to be that you just have to do a lot of math to like derive your inference algorithm and then implement that in Fortran or something. And so that is a lot more automated now and easier to do. But being honest, it's still difficult and a challenging arena. So PyMC is an advanced data science tool, and it requires solid understanding of the underlying Bayesian concepts. So yes, while it's lowering the barrier of entry compared to implementing everything from scratch, it's still a significant learning curve for someone like that doesn't know the basics. There's like fantastic learning resources, but this is also, I think, where combining this with generative AI is really exciting. One way is obviously just like Q&A and like giving people smart teaching tools, but also by building AI interfaces on top of things like that AI agent I was talking about. So no longer do you need to know all the intricacies of PyMC or PyMC marketing, which is, it also has the goal of making MMMs in PyMC much easier. But still, right, you need to be like a data scientist that knows about Python. And these are like expert models. But by providing an agent, we also abstract that layer away, and you can really just talk about it. And you don't even necessarily need to know what it's doing under the hood, as long as you trust that it's doing something sensible. So there are these specialized agents, but then also we're working on tools that follow what is called the Bayesian workflow. So essentially, how do you build a Bayesian model that's robust, right, and works well on data? So there's a couple of steps you follow and iteratively improve your model. That's a lot of what we're doing, but we're also building AI systems that can do that. You have specialized agents, for example, if you have questions about marketing effectiveness, you have agents for customer lifetime value or survey analyses, but also a general purpose agent that is able to build Bayesian models and come up with hypotheses for what the causal structure might look like, right? So this is a new problem that no one has solved before. You explain to the AI, you give it the data, and it then basically formulate these hypotheses. And that's actually, I think, also a really important innovation. Is causal discovery is like a huge topic in causality, where for the most part, what is the question that's trying to answer is what even is the causal structure behind my problem? And you can either have a lot of domain knowledge and say, okay, I already know, right? That's mostly the cases we're building with. Or you try to estimate that from the data as well, which is what causal discovery is doing. And one common approach is you just start assuming everything potentially causally influences everything else. And then you start pruning and trying out all different model combinations. But with AI that already has a lot of domain expertise, we can significantly narrow down that search space and then just have a couple of hypotheses and then use PyMC to test which of those actually explain the data the best.
Cool. So you've mentioned a lot of benefits of PyMC. If you are from a business perspective, why should a business invest or look to use PyMC or have their data scientists pick it up as a skill? What, from a business perspective, how would it be helpful?
Yeah, the main reasons are if you need trust in your answers, which is, I think, true for almost anything that you seek an answer to. You want to be able to trust in the answer you're getting. And how do you trust a black box ML algorithm, right? There are ways, right? Holdout testing. So you just know that it works, right? But you don't quite know why it works, but you know that it works. So yes, that is sufficient in some scenarios, but not in all scenarios. So sometimes you really do need that transparency in how exactly that answer was arrived at. And for that, this causal understanding is critical because we can really investigate the model and understand precisely why it answered in the way that it did. So that for me is probably the biggest benefit. And then there is a couple of things that come with that. We talked a lot about uncertainty already. You get answers that are not just, do this action or the ROI is 10%. It's always has this uncertainty around it. And then any decision that is based on not just the most likely forecast, but all the potential paths that we might forecast will provide more robust decisions. So yeah, decision making under uncertainty leads to more robust decisions. And the other cool thing that I think you can really only appreciate once you've done it is how it opens up the conversation inside of the organization. So usually the data science team would be quite siloed, and from the business units, marketing, and they get a task, just build this forecasting tool for us. And then they come back, and oftentimes there will be quite a long discussion around, how did you build this? Why did you come up with this? Because they need to be able to trust it, right? But now in a causal Bayesian framework, there is a layer where that conversation can happen. So usually the business unit will have this high level understanding already of how this problem presents itself and how it's structured. And on the level of this causal DAG, this causal graph of how these variables together, it's an excellent communication tool. So the data scientists and the business stakeholders can really collaborate on this and be like, okay, I think this thing connects to that thing and this to that. And then they hatch it out. And then you have the buy-in from the business stakeholders because they already contributed at the model development stage. And that just leads to a lot more trust and a lot more buy-in and to better decisions at the end of the day, which I think is what it's all about.
I have to agree with that. Transparency and better decision-making. Can't go wrong with either. So since PyMC is open source, what is next for it? What updates can people look forward to in the near future?
Yeah, there is a bunch of things that we're working on in different areas. One is definitely centered around scale. So overall, the type of models that we used to be able to fit, say, 10 years ago and can fit today is a huge difference. And even earlier back, it was just like toy models, right? So, this is like a cute approach, right? But we can't really use it. But by continuously pushing the edge of the technology and also, of course, having better technology, better GPUs and CPUs, we're able to fit models of like unprecedented scale and unprecedented complexity that really model all the nooks and crannies basically of your data and the structure. And there, a lot of innovation is coming from a library called PyTensor, which is lying underneath PyMC. And that is basically taking the compute graph that is your model and then doing certain simplifications on that. So just like computational efficiencies. And then we can take that and compile that to different computational backends. A lot of the benefit of AI has been around tools like TensorFlow and JAX and PyTorch, and more recently also MLX. And with PyTensor, we have functionality to compile that computational graph to all these different backends. And that is really underlying this new scalability component where, we weren't able to run models on the GPU just like 5 years ago. And now that's simple because, for example, can run anything you write in JAX just on the GPU, right? So that means any PyMC model that we compile to JAX can run on the GPU. And that has been around for a little while longer. And actually just like last week, we had our company offsite retreat in Mexico, which was awesome. And we had a lot of fun. And there was just also naturally like people just having fun playing around with technology. And one group of people started implementing a new backend for MLX, which is the Apple library for targeting specific Apple silicon chips, the M series chips, which are super powerful and actually lend themselves really well to this workflow. And we're seeing like amazing speed ups when running this on Apple hardware now. So just these types of being integrated into like the technological stack. And then there are things like TPUs, and that just like really allows this technology to to shine and run on unprecedented scale. And the second thing that I think I'm really excited about is just then the integration, really what we've been talking about here, where with Probabilistic AI, we take the targeted causal Bayesian models and combine them with generative AI tools. And there's like all kinds of different levels where that integration can happen, right? So the most obvious is on the agentic level, where we have agents that are able to use Bayesian models, build Bayesian models, interpret Bayesian models, take actions based on the outputs of those models. And yeah, so that's another area where I think a lot of, really exciting functionality is going to come from, the integration between that two. And then overall, the third arm that is like integrating is just causality in data science in general. Causal techniques have really been getting a lot of attention, and rightfully so, because they are very powerful, and a lot of work in PyMC has done towards incorporating those causal techniques like the do operator, and allowing you to build causal models and answer causal questions. So those are some of the areas where there's a lot of activity around, and where I think, a lot of great improved technology will come from.
Great. So as we talk about what's next, ODSC East is coming up pretty soon. So why don't you tell us a bit about your session, which is also on marketing mix modeling?
Yeah, very excited about that presentation. It's together with Andy Heuser, and who's also at PyMC Labs, and a system that he and others in labs have built, which is this AI agent that I talked about, that, you just upload your marketing data, you ask questions and get answers in text using very advanced capabilities behind the scenes. We have a blog post on an earlier version that is using GPT Assistant Actions API to do that, but we now have a much more advanced version that we built internally based on LangChain. So that's a framework for building these multi-agent systems, where we have multiple agents basically handling different parts of the workflow, where you have an agent that is doing the data cleaning and pre-processing, agent that knows how to do EDA on this, that then hands it over to another agent that is doing the model fitting and then the model validation, right? So all these different parts of the workflow being worked on from different agents, and that has a lot of benefits. And just provides much more robust and functioning tools. And so this is what the talk will be about, and our journey in Probabilistic AI, and what we learned building these systems and what capabilities they allow.
Great. Is that in person or virtual?
So that will be in person. I'll be in Boston, and he will be in Boston. And ODSC, I've been over the last 10 years to all kinds of conferences, always a great conference that really brings industry practitioners and data scientists together to, really, I think, provide the latest, greatest insight of what data science can bring to applied business problems.
Thank you for that plug. Always appreciated. I'll be sure to check out your session for as much time as I can afford during the conference. And lastly, since we are going to be a little lengthy here, which is not a problem, how can people follow you and your work through labs? Anything else fun you're working on?
Sure. Yeah. Mainly the central place is the PyMC Labs website. So PyMC-labs.com is for the consulting company. And we have a lot of blog posts about the topics that I've been talking about. Also just PyMC.io for the open source project, which is independent, and the associated GitHub repo. So if you're interested in contributing, we have a lot of resources to learn and also just get started contributing, and a very helpful community. And I don't do much on Twitter these days. Most of where I post is on LinkedIn. Please get in touch there. And we're always eager to chat and hear what type of problems you're facing, or any cool PyMC applications that you're working on. We love that stuff, and we love hearing from people either success stories or not so success stories where maybe we can help.
Wonderful. Yeah, I'll be sure to link to the websites, GitHub. I did take a look at the demo for that agent, that blog you sent me. Is that open source, the AI agent, or how does that work?
So it is open source. We haven't advertised it as open source because we're still like actively developing it, but yeah, core components of that or all of it will be open source, which is like really our mission. Maybe by the time the podcast drops, there will already be a link in the show notes to the repo.
Cool. And from a marketer perspective, do I need to be a data scientist to use it, or can I just go at it?
So that's the beauty of it. Yeah, it helps to be a data scientist, but it is built so that now finally these tools are available for really anyone that wants to get marketing analytics insights. So CMOs and just marketers in general. That is the goal.
Great. I will definitely check that out when I start putting the show notes together. Looked like it was ChatGPT based, or it had that structure. Is it built on that?
So that's the first version is built on ChatGPT and uses the code interpreter there. But that new version that we're going to present at ODSC is homegrown basically and can use all kinds of different backends. There's also a version that is running on Databricks that like integrates then much nicer with if you already are on Databricks, to link your existing data sources and integrate very well. And you have model runs that are then saved off to MLflow. And so, there's various versions of this for different areas of application. And very excited to show people what we have. And a lot of what we do is like custom development, right? So if there's like a need for maybe not that particular thing that we built, but something related, that's what we do. And that's, we're really excited about starting to find partners to develop these probabilistic AI systems with.
Cool. I will definitely try to stay tuned to that and keep an eye on the different versions. It sounds pretty fun from a non-AI savvy guy. All right. With that, do you have any closing comments on anything we talked about?
No, it was great chatting. Thank you so much for having me, and excited for the future.
Thank you. You as well. Been lovely chatting, and I'll stay tuned for your ODSC session in a couple of weeks.
Great. See you there.
All right. See you there. Bye.
Bye-bye.
Your engagement directly contributes to the growth and success of our community. Please subscribe now and don't miss out on the next enlightening episode. Today's episode is sponsored by ODSC East, the leading AI and data science training conference this May 13th to 15th in Boston and virtually. Learn more about the event at odsc.com/Boston, and don't forget to use the code ODSC Podcast for an additional 10% off. Supporting our podcast by subscribing not only helps our small dedicated team at ODSC, but also unlocks exclusive benefits for you.